So continuing on in chapter 8, we have a factorial expression, 10 factorial over 2 factorial, 8 factorial. So what we do is we count the 10 down, 10 times 9 times 8 factorial, till we get to the largest factorial that we can cancel it with. So we have the 8 factorial. We know those are going to cancel. What do we do with the 2 factorial? Well, it's 2 times 1. You can put that in parentheses if you want. I write that out because it could have been like 3 factorial or something else. All right, the 8 factorials cancel. Now I just have, 90 over 2 is what I have, which is 45. Okay, so that's how that one's simplified. Expand and evaluate the sum. So it's a summation. We're going from I equals 1. So the first term is going to be 1 squared plus 1. And then the next term, we're adding these terms up. Now we're going to put in 2. 2 squared plus 1. And we're going to put in 3. We're always going to this generator here, but we're putting in integers consecutively. So we're starting at 1, and then we went to 2, so there's 1, there's 2, there's 3. Now we're going to put in 4, and when will we stop? When we get to 6, the upper limit. Okay, so 4 squared plus 1. Now we have 5 squared plus 1, and then finally 6 squared plus 1. Now, how do we figure those out? Well, we're probably just going to have to figure them out. 1 plus 1 is 2. 4 plus 1 is 5. 9 plus 1 is 10. And then 16 plus 1 is 17. So we're going to add these up. 25 plus 1, which is 26. And then 36 plus 1, which is 37. So you could get a calculator if you wanted to for this. I'm trying to see if there's an easy way to do it. I'm not really seeing it. 17 and 37, what's that? 54. And then the 26, so that makes 80. And then there's another 10, which is 90. And then the 2 and the 5. So I'll say 97. But maybe I should do it on a calculator to check. Yeah, it was 97. I was just checking. Okay. Now we're getting into an arithmetic sequence. So we have formulas for arithmetic and geometric sequences. Those are on the formula page. Okay, so to find a term in an arithmetic sequence, it's a sub n equals a sub 1 plus n minus 1 times d, that common difference. Okay, we are finding the 8th term. That means n equals 8. So a sub 8. The first term is 4, so that's a sub 1 is 4. Now, what's n? 8, because we're saying we're finding the 8th term. And then the common difference is negative 7. So they tell us everything we need to know. We're finding the 8th term. First term is 4, n is 8, and the common difference is negative 7. So a little bit of math. 4 plus parentheses, which is 7, times negative 7. So we have 4 plus a negative 49. What's that? Negative 45? So a sub 8 is negative 45. Now, if you really wanted to check that, you could start at 4 and keep subtracting 7 and do that to like 7 times, right? And you would get negative 45. All right. Find the sum of the first 100 terms of the arithmetic sequence. So here's an arithmetic sequence. The formula for the sum of an arithmetic sequence is n over 2 times a sub 1 plus a sub n. And we're going to find the sum of the first 100 terms. So we're finding s sub 100. N is 100. We know the first term, that's 1, but we don't know the last term. So how do we find a sub 100? Because the last term, see, this is going out to a sub 100. We want to know what the 100th term is. We need to know that. So we go back to that formula we had a minute ago. Let me erase. Let me put that formula back. A sub n equals a sub 1 plus n minus 1 times d. Okay, so we are finding a sub 100. and that's going to equal 1. That's the first term. That's a sub 1 there. Plus 100 minus 1 times d. Now, what's the common difference? What do you keep adding there? 2, right? Okay, so 1 plus 99 times 2, or 1 plus 198. Okay, and that's going to be 199. That is what a sub 100 is. That's the last term that we're adding up. So we're going from 1 to 199. That's the last term. And then we want to add all those terms up in between that have that common difference. Okay, so a sub n is going to be 199. And so now we do a little math. 50 times 200, or 10,000. Okay, so I verified it on a calculator, 10,000. If I really wanted to verify it further, I would add up 1 plus 3 plus 5 plus 7 plus, and I would keep going till I got to plus 199. That would take me too long. I'll stick with what I have.